The approximate current draw difference between a 400-watt metal halide fixture and a 1000-watt metal halide fixture on a 208-volt system is significant. The customer is considering replacing 2400-watt fixtures with 1000-watt fixtures. Understanding the current draw implications is important for electrical load calculations. Let's examine the calculations. A 400-watt fixture operating at 208 volts draws approximately 1.92 amps. This is calculated by dividing the wattage by the voltage. 400 watts divided by 208 volts equals 1.92 amps. Now, let's consider the 1000-watt fixture. A 1000-watt fixture operating at 208 volts draws approximately 4.81 amps. Again, this is calculated by dividing the wattage by the voltage. 1000 watts divided by 208 volts equals 4.81 amps. Therefore, the approximate current draw per 400-watt fixture is 1.92 amps, and the approximate current draw per 1000-watt fixture is 4.81 amps. Replacing a 400-watt fixture with a 1000-watt fixture will increase the current draw by approximately 2.89 amps per fixture. This is obtained by subtracting 1.92 amps from 4.81 amps. Since the customer plans to replace 2400-watt fixtures with 1000-watt fixtures, the total increase in current draw will be substantial. The total increase is about 57.8 amps. This is calculated by multiplying 2.89 amps by 20 fixtures. It's important to ensure that the existing electrical infrastructure can handle the increased load. This includes verifying the capacity of the circuit breakers, wiring, and any other relevant components. Overloading the circuit can lead to overheating, trip breakers, and potentially hazardous situations. A licensed electrician should be consulted to assess the electrical system and ensure that it can safely accommodate the increased load. The electrician will consider factors such as the wire gauge, conduit size, and breaker rating to determine if upgrades are necessary. Furthermore, it is important to consider the inrush current associated with metal halide fixtures. Metal halide lamps typically have a high inrush current when they are initially turned on, which can be several times the normal operating current. This inrush current can place additional stress on the electrical system and may require the use of slow-blow fuses or circuit breakers. The National Electrical Code, or NEC, provides guidelines for sizing conductors and overcurrent protection devices for lighting circuits. It is important to adhere to these guidelines to ensure a safe and compliant installation. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their size and insulation type. The electrician should consult this table to select conductors that are suitable for the expected current draw. Additionally, NEC Section 430.22 provides requirements for sizing conductors for motor loads, which can be applied to lighting circuits with similar characteristics. The electrician should also consider the voltage drop in the wiring. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the source. Excessive voltage drop can cause the lights to be dimmer and can also damage the equipment. The NEC recommends limiting the voltage drop to no more than 3% for lighting circuits. The voltage drop can be calculated using Ohm's law and the resistance of the wiring. The resistance of the wiring depends on the wire gauge, length, and material. The electrician can use a voltage drop calculator to determine the appropriate wire size to minimize voltage drop. In addition to the electrical considerations, it is also important to consider the lighting requirements of the parking lot. The 1000-watt fixtures will provide significantly more light than the 400-watt fixtures. It is important to ensure that the light levels are appropriate for the intended use and that the lighting is uniform and does not create glare. A lighting designer can be consulted to perform a lighting analysis and determine the optimal placement and aiming of the fixtures. The lighting designer will consider factors such as the parking lot dimensions, surface reflectance, and desired light levels. They will use specialized software to simulate the lighting performance and generate a lighting plan. The lighting plan will specify the location, type, and aiming of the fixtures. It will also provide information on the expected light levels and uniformity. Furthermore, it is important to consider the energy efficiency of the lighting system. Metal halide lamps are relatively inefficient compared to other lighting technologies such as LED. LED lamps offer significant energy savings and have a longer lifespan. Consider upgrading to LED fixtures instead of replacing the metal halide fixtures with 1000-watt metal halide fixtures. Although the initial cost of LED fixtures may be higher, the long-term energy savings will offset the higher cost. In addition to energy savings, LED fixtures also offer other benefits such as improved light quality, reduced maintenance, and instant on/off operation. Furthermore, LED fixtures are available in a wide range of colors and light distributions. This allows for greater flexibility in designing the lighting system. The electrician or lighting designer can provide information on the available LED fixture options and help to select the best option for the specific application. Consider the environmental impact of the lighting system. Metal halide lamps contain mercury, which is a hazardous material. When the lamps are disposed of, the mercury can contaminate the environment. LED lamps do not contain mercury and are therefore more environmentally friendly. Many utilities offer rebates and incentives for upgrading to energy-efficient lighting systems. These rebates and incentives can help to offset the cost of the upgrade. Contact the local utility company to inquire about available rebates and incentives. The rebates and incentives may be based on the energy savings or the type of lighting technology used. The application process for the rebates and incentives may vary depending on the utility company. The electrician or lighting designer can assist with the application process. In summary, replacing 2400-watt metal halide fixtures with 21,000-watt metal halide fixtures on a 208-volt system will significantly increase the current draw. It is important to consult with a licensed electrician to assess the electrical system and ensure that it can safely accommodate the increased load. The electrician will consider factors such as the wire gauge, conduit size, and breaker rating. It is also important to consider the lighting requirements of the parking lot and the energy efficiency of the lighting system. Consider upgrading to LED fixtures instead of replacing the metal halide fixtures with 1000-watt metal halide fixtures. Finally, consider the environmental impact of the lighting system and the availability of rebates and incentives. Before undertaking any electrical work, it is crucial to prioritize safety. Always disconnect the power supply to the circuit before working on any electrical components. Use appropriate safety gear, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult with a qualified electrician. Working with electricity can be dangerous, and it is important to take precautions to avoid electrical shock or other injuries. Familiarize yourself with the National Electrical Code, or NEC, and follow all applicable safety regulations. Proper planning and execution are essential for a successful lighting upgrade project.